In this tutorial, we will be going through how to install your operating system. You will go into Linux straight away, skipping the read through 20 slideshows before you can actually type in your first command approach. We'll look over how text editors work, VM, users, group management, permissions, the basics of shell scripting, features that are very useful when using Bash, process management, OpenSSH servers, compression and archiving, and so much more. And as stated before, you won't be learning this off of a slideshow. In fact, at Ultra Learning Linux, we have prepared a whole new different approach, starting with following along with every chapter by focusing more on actually doing and not just hearing someone reading through a slideshow. You being the one that drills in the actual experiences, you'll find yourself acquiring more knowledge than ever. We tie everything up with some of the most common questions you get asked when going for an interview. And with that being said, I can't wait for you to learn Linux. I mean, Ultra Learn Linux in a simple and actually fun, non-stressful way. Now, in order to maximize your ultra learning journey with Linux, I will advise you to first watch one chapter at a time. The first time you watch a chapter, just take in the information without taking any notes, no stress, no pressure, just to get a feel for it. Now, as you start watching the chapter again, try to follow along more closely, or take mental notes or actual notes. Pause if needed to better comprehend the information, and remember, there's no hurry. You might need to watch a chapter a few times before you can fully grasp its concepts, and that's okay as well. That's why we encourage you to just watch for the first viewing of every chapter, just to have a more relaxed and pleasant approach. Don't stress yourself out before you even begin. Just enjoy as your ultra learning journey begins now. Before we begin, we will have to download and install CentOS on our computers. This will be the Linux distribution we will be using throughout this tutorial. First, go to google.com or any other search engine and type CentOS 7 download ISO. Now click the second link, Index of CentOS 7 ISO. Select the x86, 64, everything 2009 ISO. You need to remember that your computer architecture must be 64 bits. If it's 32, you'll have to use the 32-bit ISO. That being said, I will be waiting for my download to finish and move on to the next part. Now we can download our VirtualBox at www.virtualbox.org. Here we can click on the big Download VirtualBox button. You will select the VirtualBox package for your computer operating system, which will host our VirtualBox VM. Don't worry about the different versions, they are often updated so version might differ. If you are using Windows for this tutorial, pick the Windows host. If you are using Apple, you have to select the OS X host. After we downloaded our VirtualBox, we can then proceed to the next setup by double-clicking the installer and continuing the process for this section. We'll leave everything as default for this tutorial. Very good. That was about it for downloading and installing our virtual machine. First, let's open our Oracle VM VirtualBox Manager, where we will create our first virtual machine. All we have to do is click on this new button. As a name, we will be using CentOS. That will be just the name of our virtual machine on this VirtualBox. Obviously, you can pick any name, but this will make it easier for you to follow along. By default, it is already picking on Linux as a type, and this will be the version 64. If it shows 32-bit, then you might have virtualization feature turned off. If it's 64, then go ahead and continue. I will leave a simple walkthrough on how to turn your virtualization feature after this guided video. For the memory size, I usually go about with 1024 megabytes. Next, you need to create a virtual hard disk. By default, this would be around 8 gigabytes, but go ahead and change that to 25. Just to be safe. Select Create a Virtual Hard Disk now. Here we select VHD, Virtual Hard Disk. Select Fixed Size, and for the size, go with 25 gigabytes. Now that our virtual machine is created, go ahead and click on Start. Once we start it, we need to attach the ISO image we downloaded earlier. Select your folder. In my case, it will be desktop. Now select Install CentOS 7. After we install CentOS 7, we will need to configure it as well. You can disable this small error. Quick note, if your mouse gets stuck, you can use the right control to have it unstuck. For this tutorial, we will be using English. For language support, we will go with English. Keyboard as English, US. As for the software section, we already have this configured with the right source. Now, for the software selection, go ahead and select Server with Kai. As for the system, select Installation Destination, meaning where do you want to install this operating system. Remember, we picked the 25 gigabytes, so we'll go ahead and select this one, and by default, we already have this one selected. Network and hostname. Now, click on Configure. The only thing you have to click is the General tab and select Automatically Connect to this network when it is available. As you can see, now we are connected. Now we head back and click on Begin Installation. On this page, while the installation is ongoing, we need to create a root password. Go ahead and click on Root Password. Root is the system administrator in Linux. Now, select your password. After you say your root password, I want you to create a user as well. Depending on your system, the installation might take anywhere from a few minutes to an hour. I'm going to fast forward with the installation for now. Very good. Now, all you need to do is click on the reboot button. Click on Licensing and read through it. After you finish reading, click I accept the license agreement. If you do, of course. You don't need to configure the hostname because we already done this in a previous step. Now, just go ahead and click Finish Configuration. This means we configured everything as we wanted. Now, click on your user and get ready to dive into your Linux experience. On many systems, the hardware virtualization feature first needs to be enabled in BIOS before VirtualBox can actually make use of it. So how do we enable virtualization on our computer? Well, first let's make sure that your virtualization is in fact disabled. For that, let's first click on Windows key on your keyboard. Then type in Run and hit Enter. Very good. Now type CMD and hit Enter again. As we have CMD open, we shall type in systeminfo.exe and hit Enter again. After it loads, look at the Hyper-V requirements. Here you should be able to see if your virtualization is either enabled by saying yes or not enabled by saying no. If it's turned on, then you can continue with the next chapter in this tutorial and stop this video right now. If it's turned off, then we'll move on to our Windows Start menu. Once here, just click on Settings. Go to Update and Security. Once we have this tab open, we'll just click on Recovery. On the Advanced tab, Start Up, find Restart Now and just click it. Once you see this blue screen, click on Troubleshoot, go to Advanced Options, click on UEFI Firmware Settings. Click on Restart to enter System BIOS. Now, this is how we change the BIOS on an Intel-based system. First, enter Advanced Mode. Go to Advanced. Enter CPU configuration. Enable Enter Virtualization Technology. Very good. Now, just exit BIOS and save the changes. If your BIOS looks different, enable any of the similar options. Intel VTX, Intel Virtualization Technology, Virtualization Extensions, or Wonderpool. Once enabled, just save your new BIOS settings and restart. This is how we change our BIOS settings on an AMD-based system. Enter Advanced Mode. Go to Advanced. Enter CPU configuration. Enable SVM mode. Now exit BIOS by saving the changes. If your BIOS looks different, just have a look for CPU settings in your BIOS. Enable any of these similar options. AMD V or SVM, AMD Virtualization Technology, virtualization extensions or Wonder pool. After that, just save the new BIOS settings and restart. With that being said, we have finished our first chapter, installing CentOS on your computer. After you log in into your account for the first time, you'll get greeted with this welcome screen. As we already have our language selected, we can simply click Next. My keyboard type is English US, so I'll just click Next again. Location off, then click Next. Skip the online account, and lastly click on Start using CentOS Linux. Close the Getting Started tab. Now go over to Applications, hover over to System Tools, click on Settings. From the Settings tab, scroll all the way over to Devices and select it. Now for resolution, select 1920 by 1440 and Night Light on. Click on Apply and then on Save Changes. After that, from the same Device tab, click on Mouse and Touchpad. Here, adjust your mouse speed as you desire. I usually turn mine all the way down. Now click Back. From the Settings tab, click on Background. You can either upload something you want or just use one of the colors. In my case, I'll go with blue, and I'll set the same for the lock screen. After completion, just exit the page by clicking the X on the right hand side corner of the tab. The last thing we're gonna do is just go back over to Applications, hover over System Tools, and then select the terminal and drag it to our desktop. Very good. You just finished subchapter 1. As far as Linux goes, there are plenty of commands and syntaxes to go on for days, but for this chapter we'll be focusing on the most commonly used and the ones you will potentially use most often. So first and foremost, let's access our terminal. From here we'll be using our first command. For our first command, we will be typing pwd, then hit enter. As you can see, our terminal has displayed the current working directory we're in. pwd stands for print working directory. You also have to keep in mind that Linux is key sensitive, so if we were to type capital pwd or capitals, these commands would not work. You will need to remember that Linux is key sensitive, especially when naming your files and directories, passwords, and so on. Very good. Now that we know where we are, where the current directory is, why don't we display the content of this directory? For that, we'll be using the ls command, which stands for list files. Type in ls and hit enter. Very good, you have listed your files in Linux. By listing your files, you now know what the content is for /home/Mario, in this case my username. Very good. So far you've used pwd and ls, but let's say for example we wanted to check the username we're logged in right now. Well, in order for us to know what username we are logged in right now, all we have to do is type who am I and hit enter. As you can see, in my case it displays Mario. In your case, it should be your username. Very good. Now, in order to maintain a clean aspect of your screen, we can use the clear command to erase everything that was displayed previously. So let's type in clear and press enter. Navigating the Linux file system from the terminal is an essential skill. So in order to do so, we will introduce the changing directories command, and that is cd. First, let's print out the content of our directory by typing ls and hit enter. Now, let's say we want to go into our music directory. We would just type in cd music and press enter. Now let's type in pwd and see what directory we are in right now. Very good. Now, in Linux, there is a relative path and an absolute path, but we will be covering that in more depth in subchapter 3. Now, once we're in the music directory, we'll go ahead and list its content. Type ls again and hit enter. As we can see, nothing got printed because this directory is actually empty. Now, to head back to our previous directory, we just type in cd ... and now we'll print our working directory by typing in pwd and hitting enter. Very good. Also, every command in Linux, you need to remember, has 3 parts, and those are the actual command that you run, for example ls, and then the option that will define the behavior of the command. For example, we can use ls -l, and now we are displaying the content of our directory in depth, showing permissions, groups, and so on. And then the argument that just follows the command and could be one or more. For example, if we wanted to print the content of our music directory while we were still in our current directory, we would simply type in ls -l music. As you can see, we have gotten a message, total 0, meaning that our directory is empty. Very good. Now, just before we move on to our next subchapter, I want to mention two very useful commands, and those are man and --help or -h. What these commands do is help the user get a better understanding of what a command actually does. As we had our ls command, if we were to type in man ls, it will display the reference manual page. We'll be greeted with the actual name and the synopsis of the command, and how the command works, and the description for the commands and options. To navigate, you can simply use your up and down arrows, and to exit, you simply press Q. Same goes for --help. If we were to type ls --help, we will display the current listing information. To navigate this up and down, just use your scroll mouse wheel. And that's about it for this subchapter. Congratulations, you've just finished. Linux uses a logical file system, the structure being different from Windows because Linux doesn't have a physical drive, such as a C drive. At the very top of the file system, we have /, often referred to as the root file system, as if it were an upside-down tree. Keep in mind that this is different from the root user. At first, terms may be confusing, but they'll become much easier to understand once you get used to Linux. So this is how a file system tree actually looks like. First of all, we got the root, the / at the top of the tree, followed by the most important subdirectories. The first one being /root, the home directory of the all-powerful root user, /etc. etc stands for editable text configuration, generally contains the Linux configuration files. Now, these are files that control when and how programs start up, many of them end in .conf, and are basic text files we can edit in our editor. /home, this is the user's home directory. Here we will find a folder name after each user on the system. /bin is where the application binary resides. These are basically the equivalent of executables in Microsoft Windows. Then we got the /sbin. The sbin contains executables that should only be executed by the root user, like mount or delete users and so on. /lib, where you'll find your libraries, shared programs that are similar to Windows DLL. User contains non-essential installed binaries to the operating systems and are intended for the end user. We also have a /local directory under the /user that will contain any binaries that we compiled manually to provide a safe place that won't conflict with the other software installed by the package manager. /boot contains the files needed to boot the system, as in the Linux kernel itself. /dev, that stands for device files. Here we can interface with the hardware or drivers as if it were regular files, so you may create disk partitions or interfaces with your floppy drive or so on. var contains variable files that will change as the operating system is being used, things like logs and crash files. A temp file stands for temporary files that won't be persistent between reboots. And last but not least, the proc directory. The proc directory is an illusionary file system that doesn't actually exist on the disk, but is created in the memory on the fly by the Linux kernel to keep track of the running processes. When you're navigating to Linux, it's important that you are as efficient as possible, for these features will come a long way. Now let's have a look at the absolute path. An absolute path describes the full path beginning with the root @ followed by each subdirectory until we reach the specific file or destination we wanted. An absolute path defines every file that exists on a Linux system, and it can be identified using a very simple rule. If the first character of the path is /, then it implies that this is an absolute path name. Let's see the following example for a better understanding. First, be sure to be logged into your user account and on your terminal. Using your terminal, type in pwd. As you can see, we are in the /home/Mario directory. Now let's use the absolute path to move to the root directory. Type in cd/. Very good. Now let's use pwd. Good. We are in the /root directory. Let's see what this directory contains using the ls command. We'll type in ls and hit enter. As you can see, we have a lot of subdirectories in root. Let's use the absolute path to navigate through them, just to grasp the concept a little bit better. Now we would like to see the user directory. For that, we'll simply type in cd/user and hit enter. We can now type pwd, and as you can see, we're in the user directory, and we got here using the absolute path. Now let's list the content of this directory by typing ls. Very good. Now just to make this more clear, we can type cd/. And now we can type pwd to see the directory we're in. And there we have it, we're back in our root directory. Now to move from here to our /user/games directory using an absolute path, simply type in cd/user/game and hit enter. Now type pwd, and as you can see we are in our /user/games directory. Now let's just navigate back to /root by typing cd/ and hitting enter. Once in the / directory, aka root, we can use the pwd to make sure everything is aligned correctly. Very good. Now the relative path refers to the unique path which is required to reach a file, but the path can only be used from the current directory that you are in and does not start with the root, the /. That being said, let's see now, we're in the root directory, so let's list the content of it by typing ls and hitting enter. We want to go into our user directory. For that, we simply type in cd user and hit enter. Very good. Now pwd, hit enter. Now let's list the content of this directory by typing ls and hitting enter. And let's go to the game directory by simply typing cd games. Now type in pwd to see the current directory. Very good. We managed to move from the /root directory all the way to our games directory using the relative path this time. Now let's get back to our root/root folder. Using the same method, we'll type in cd ... Now type in pwd. Voila, we've reached the same goal using the absolute path method and the relative path method as well. If things are not clear yet, I'll make a Windows associated example for you to better comprehend the concept. We often use the relative path to navigate from one folder to another, from your computer to your C drive to your Windows folder and all the way to your boot folder. We basically navigated our way to the boot folder the same way we navigated to our games directory using the relative path. And now, if we have a look at the top of the Windows folder, we can see the absolute path, which is c/windows/boot. I really do hope that these examples have made it more clear on how and why we use the relative pathing and the absolute pathing. There is no right way, to be fair. It's what you feel works best for you. With that being said, you just completed subchapter 4. After you get familiar with the way we navigate our Linux system, we'll move on to actually creating files. The first command we're going to look at is the cat command. The cat command followed by a file name will display the contents of that file, but to actually create that file, we follow the cat command with a redirect and the name of the file we are creating. Here's a quick example. First, let's make sure we're in the home directory. We'll type in pwd. In my case, I'm in my home directory. If you're not, just navigate your way there. Once in your home directory, we will just type in the command cat redirect my first file. After we hit enter, Linux will go into interactive mode and will wait for us to enter our actual content for the file. So now we can just type in this is my first file in Linux and hit enter again. Then to exit, we simply press Ctrl+D. Voila, we just created our first file. Now let's see the content of our directory by typing in ls. And then to actually see the content of our file, we just type cat and the name of my file, in our case, my first file, and we receive the line of text contained in my first file. Very good. Now, in order to add more content to our first file, in order to append, we will have to use the double redirect, followed by what you want to add at the end of the file. For example, we'll type in cat double redirect my first file. Then add the following text. I just added my first line. Now press Ctrl+D. Very good. Now let's read the file again. We'll type in cat, my first file, then hit enter. And there we go. We now have 2 lines of text in our first file. Keep in mind that if we were to use cat with only one redirect, then our previous file will be completely erased. For example, let's clear everything by typing in clear. Then see the directory by typing pwd. Now we're going to list its content by typing ls. Then we're going to type cat, redirect my first file, with the line, only new text goes here. Then do Ctrl+D. Now let's read the file using cat, my first file. Hit enter. As you can see, we only have the last line we added, and the other 2 got erased. So keep in mind when using the cat command to append more information, you always have to use the double redirect. The second command for creating a file is touch. This command makes it so a user could simply touch a file to change some of its details. If applied to an existing file, it updates its timestamp to the current timestamp without actually modifying the content of the file. And if the file doesn't exist, it will create an empty file with that file name. Now let's type clear, make sure you're in our home directory by typing pwd and hitting enter. Very good. Now listing its content, ls, and we'll type in touch my second file. List the content of our home directory again by typing ls. Now let's use the ls-l. Here we can see that the file we just created has its size 0 because there is no content in my second file. And there we have it. You've learned 2 ways of creating files. Now that you learned how to make files, we'll learn how to make directories. For that, we're going to use the command mkdir. Now let's clear the screen one more time by typing in clear and hitting enter. Good. You saw how easy it was to create our files, but if we were to print the content of our directory, we'll do ls. You can see we only have directories here. There are no actual files except for the ones we have created. So let's keep it clean and create a directory and move our files there. To create our first directory, we will just type in mkdir followed by the name. So let's type mkdir chapters. Now list the content of our directory by typing ls, and there we have it, our first directory named chapters. Now let's navigate to chapters using the relative path. We'll do cd chapters. Now use pwd and hit enter. There we go. Once in the chapters directory, create another directory with the name chapter 2. We'll type mkdir chapter 2, and then we'll type ls and hit enter. There we have it, we just create another directory. Now let's head back into our home directory. Using the relative path again, we'll do cd ... and hit enter. Now let's type pwd and hit enter again. Here we are back in our user home directory. We also got the move command, mv. Now let's print the content of our directory again by typing ls and hitting enter. Then use the move command, the mv command, to move our first and second file to the right chapter. For that, we will use the relative path again. Type in mv space my first file space my second file space chapters / chapter 2. Keep in mind that using tab while using Linux is a key aspect that we will be using. Tab allows you to autocomplete most of your commands and tells you the content of your directories. But for now, don't focus on it, just try and understand these simple concepts of creating and moving files and directories around. So now that we have moved our 2 files in the desired directory, let's see our results using 3 methods. For the first method, we will be using the relative path again. Just type in ls chapters / chapter 2. Very good. Now you can see our files were moved in the desired directory. For our second method, we'll be using the absolute path. We'll first type in pwd. So now that we know where we are, we'll just type in ls / home / Mario / chapters / chapter 2. And there we have it. We've just listed the content of our directory using the absolute path method. And for the third method, we will be simply navigating all the way to our chapter 2 directory using the relative path method. Now let's see the content of our directory. We'll type in ls and hit enter. Then type cd chapters. To move into the chapters directory, to double check that, type pwd and hit enter. Very good. Now we'll type in ls again, and finally we'll do cd chapter 2 and hit enter. And then we'll print the content again by typing ls, and there we have it, our files are here. Now keep in mind there's always more approaches to every task. It all comes down to how you apply the knowledge you have acquired. That is why in Ultra Learning, we focus on actually doing, not just reading through slideshows for hours. Now let's clear this and move up a directory again. Then cd ... hit enter. Very good. Now we do have the copy command, and that is cp. Just keep in mind that if the file already exists, the cp command overwrites the file. Now we always want to back up our files, just in case they get damaged in any way. So to make sure you're in the chapters directory, type in pwd now. List the content by typing ls and hit enter. Very good. So then let's create a directory backup. We'll be typing in mkdir backup, hit enter. Now we'll list the content by typing ls and hit enter again. Very good. Now let's move back into our chapter 2 directory. We'll do that by typing in cd chapter 2. Very good. Now ls and hit enter. We still have our 2 files, so let's copy them into our backup. In order to copy files, we use the cp command. Before we do that, let's check the content of our backup directory. We'll do that by typing ls /backup. As you can see, the directory is empty. Now using the relative path again, we'll type in copy, as in cp, my first file, space my second file, space .. /backup. Now we're going to list the content of backup again by typing in ls .. /backup. And there we have it, we just backed up our first files. So now let's say we're running out of space on our system and we need to make more room. We can accomplish this by deleting the files in our backup directory. In order to do so, first we'll be using our absolute path method to navigate there. So we'll just type in cd/home/mario/chapters/backup. Hit enter, then list the content of it by typing ls and hitting enter again. Then type in rm, my first file, and hit enter. We'll do ls again to see the content. There we go. Then removing the second file by typing rm, my second file. So we just cleared up more space on our system and learn how to use the rm command. Very good. Now let's navigate to our /home/Mario directory using the absolute path. We'll do that by typing in cd/home/Mario. And from here we'll list the content of our directory by typing ls and hitting enter. Good. Now that we're finished with this part of the chapter, we'll just want to delete our chapters directory. We will try and do that using the remove command by typing in rm chapters. But we can see we're getting an error. We cannot remove this directory chapters because it's a directory. The reason we are receiving this is because chapter is not an empty directory. So every time you want to delete a directory that is not empty, you will have to add the -a that stands for recursive. Let's give that a try. So we'll type in rm -a chapters. Now listing the content using ls. There we go, we just removed our chapters directory. Keep in mind that whenever deleting directories, you will not be able to restore the information and will be permanently deleted. Beware and use with caution. Now, don't worry if you can't comprehend everything just yet. It wouldn't be called learning after all if you already knew everything. Just give it time, watch the lessons again and do the exercises again, and you'll find that these lessons are actually quite easy. All you have to do is add value to your craft by doing it. How to change the root password in Linux. The method I'll be using will be the same for most Linux systems. Once we're in our terminal, we'll be typing su command, which stands for superuser, this being the normal way of logging into your root account. Once we hit enter, it will ask for our password. Once I type my password, you can see it says authentication failure. The reason for receiving this error is because the root account is not configured by default, and so our personal user password will not work. I'll be showing you how to solve this issue. First, you'll have to type sudo -i and press enter. Then type the current password for your user account. Press enter again. Now type passwd and hit enter. And now it will ask you for a new root password you want to set. Choose your password. Just have it different from your user password. We type the password again and hit enter. Very good. Now you have successfully changed your root password. In order to check if this was successful, log out of your root account by typing exit, then type su again, enter your root password, and there we have it. We have changed our root password. In this chapter, we will learn how to create, view and edit text files on a Linux operating system. We will also learn how to edit existing text files on a command shell prompt using the tool known as VM. That being said, let's make sure we're in our /home/Mario directory. Type in pwd and hit enter. Very good. Once in our home directory and user directory, we'll be creating a directory named text. So we'll type in mkdir text and hit enter. Very good. Now let's navigate to our text directory. We'll type in cd and text. Now we'll type in pwd just to check our current directory. Now let's create our first text file using the cat command. For that we'll be typing in cat redirect text1. Now for the text we'll be typing in, this is our first text line. We'll hit enter and then Ctrl+D. Now let's clear the screen by typing in clear. Very good. Now let's see the content of our current directory. We'll type in ls and hit enter. And there we go. Our text file is created. Now, if you remember, in order to add more text to our file, we'll need to append by using the double redirect symbol. So we'll do cat double redirect text1 and hit enter. We'll type in, this is our second line of text. Press enter again and then Ctrl+D. Now using cat on our text1, we can see we got 2 lines of text. In Linux, we can also redirect the output from another file or command. For example, if we typed in date to see the actual date of today, type in date and hit enter. Very good. Now, if we want to redirect the output of our date command to our text file, in order to remember when this text file was created, for example, we would simply type in date followed by the 2 redirect signs and lastly text1. Now we can just type in cat text1 and hit enter. And there you have it. We just added today's date to our text1 file. Very good. This will conclude this short subchapter. One of the key design principles of Linux is that information is stored in text-based files. The advantage of text files is that they can be viewed and edited using any simple text editor. VM is the most popular text editor across all Linux and Unix systems, being an improved version of the VI editor. VM is highly configurable and efficient for practiced users and comes pre-installed with most Linux systems. VM works in 4 modes: edit mode, command mode, visual edit mode, and extended mode. So, before we do start our VM editor, we will first copy a text file from our /etc directory. So let's navigate to our root directory by typing in cd and /. From here, we'll do ls and then type in cd etc. Now let's list the content of etc directory using the command ls and hit enter. From here, we'll copy our yum.conf text file. We'll type in cp yum.conf /home/mario. Very good. Now moving to our user directory, using the absolute path, we'll be typing in cd/home/mario. And then we're going to list the content of it by typing in ls and hitting enter. We now have our own yum.conf file that we can edit. First, let's read our text file using cat. Very good. Now let's clear the screen and use our VM editor. The very first thing we're going to do is edit a file using VM. So just type in vm yum.conf and hit enter. You can notice that if you were to type anything right now, nothing would actually happen because we are in command mode. So in order to actually be able to quit VM, we would simply need to type in column and q. And as soon as we hit enter, we'll just leave the program. Now let's enter VM again. We'll use the up arrow to get the last command and hit enter. So there are a few other commands. For example, if you wanted to save the changes, you'd have to type in column W and hit enter. And now your changes would have been saved. If you were to write column WQ, this would save the changes and quit the program all at the same time. Now, if you wanted to quit the program without actually saving anything, you'd have to type in column Q and the bang, which is the exclamation mark. Very good. Now let's just begin actually editing. So we already know that the mode we get started with is command mode. So you could set commands here like column set number. This is a source code file and this command turns on line numbering. Now in order to insert text using VM, we need to go into a different mode. The way we do that is by hitting I to get to insert mode. Now you can type this line here. So if we want to run commands again, we would just hit escape and that gets us back to the command mode. Now you know how to enter insert mode, how to save, how to quit. You can pretty much do anything you can do in a normal editor. Although that is true, you will be very slow at actually editing. So that's why we're going to go over a few more points in regards to VM. Now in our command line, if we want to delete some lines, we can simply just type D twice and our line will be deleted, just like that. That was DD delete line. For example, if we want to leave 4 lines, we could just type in 4 in front of DD and that will delete 4 lines. But sometimes you might want to undo some of the damage you've done actually while inserting. If so, all you have to do is hit escape to get back to command mode, and here you can type U and that will undo the last command. You can keep hitting U and that will undo again and again. And if you want to redo, you just hit Ctrl and R and that will redo your last action. So there we got U to undo and Ctrl R to redo. Very good. Now if we want to search something in our editor, we'll just type in the / followed by a search string and hit enter. And there we have it. That simply searches for whatever we typed in. You can move between the results by typing in lower N to move forward and uppercase N, basically shift and N to move backwards. This is a simple search that we can perform in VM. That being said, you just finished chapter 3. Linux is a multi-user system. That means you can have multiple users, each having different levels of access to files, folders and programs installed on the same system. In Linux, the root user is all-powerful. The root user can do basically anything on the system. Other users on the system have more limited capabilities and permissions and almost never have the access that the root user has. We could have the users Smith, Alice, and John. Then we have groups Groups is a very good method to organize the actual users on the system. For example, we could have students as one group, and then we can put all the users that are actual students, like John and Alice, in it. Then we could have a group called teachers, where we could put all the teachers, in our case, Mr. Smith, so each group can have multiple users in them. Now, by default, every user account that you create gets a default group. This is the same as the username. The idea is to put people with similar needs into a group that is granted relevant permissions. Then each group member inherits the group permissions. Now that we covered these basics, let's see how we can actually put them into use in a real-world environment, and we'll see that in our next subchapter. The root user is part of the root group by default. Each new user on the system must be added to a group in order to inherit the permissions of that group. Now, in order to create a new user, we'll use the command line as typed in sudo space user add space -m Alice. This is for the username Alice. After we create the user, we also have to set up a password for it. So we'll do that by typing in sudo space passwd space Alice, and we'll set the new password for Alice, our newly created account. Alright, now let's create another user named John. We'll do that by typing in sudo space user add space -m space John, then type in sudo passwd John. Then we'll hit enter. Now we'll set the password for John as well. Very good. Now let's create our last username by the name of Smith. We'll type in sudo space user add space -m Smith and sudo passwd Smith to set a password for this user now. Nice. Now in order to create a group, we will type in sudo space group add students, or the name of the group you want to create, but for this example we'll use students, and then hit enter. This will create a new group named students. Now let's create another group named teachers. We'll do that by typing in sudo space group add space teachers. Very good. That will conclude our subchapter 2, creating users and groups. Now that we have created our groups, the next step is to add actual users to these groups. To accomplish this, we will be using the usermod command. So in our terminal, we will type in sudo usermod space -a to append, and then space -G for groups. Then type in the name of the group. In our case, we'll be doing the students and the teachers group, and then the name of the user you want to include. In our case, we'll have Alice, John, and Mr. Smith. So first, we'll add the students Alice and John to the students group. In order to do so, we'll be typing in sudo space usermod space -a space -G students space Alice. Now we'll add John as well. We'll do that by typing in sudo space usermod space -a space -G students and then John. And in order to add our teacher, Mr. Smith, to our teachers group, we'll simply type in sudo space usermod space -a space -G teachers and then Smith. Very good. We just added user to their groups. This will conclude this short subchapter. In Linux, there are 3 levels of permissions. The R, permission to read. This grants permission only to open and view a file. The W, permission to write. This allows users to view and edit a file. And lastly, X, permission to execute. This allows users to execute a file, but not necessarily to view or edit. So we got the R, the W, and the X entries applied to these 3 user-based permission groups. The owner, which is you, the group, and then all users. So by default, the root user can grant users a level of permissions depending on what they need for the files. As mentioned previously, when a file is created, typically the user who created the file is the owner of the file, and the owning group is the user's current group. So for example, imagine there's a computer at a school that contains 2 folders. In our case, it would be directories. But let's say the first folder there will be the lessons folder, and the second one would be the actual exams. The way we want to set this up for our students is to have access to the lessons document, but not to be able to access the actual exam documents, and the users in the teachers group would have access to both. There are 2 ways of setting up permissions in Linux. The first method is using the cown or the chmod group command, and the second one is the FACL, that stands short for File Access Control List. We will go over both of them, so let's start with the first one. For the first method, we'll be using the chown and chmod command. We can use chgroup instead of chown, but for now we'll be using chown. Very good. Now let's navigate into our /home/user directory, in my case Mario. Once we're here, just to make sure, type in pwd and hit enter. Now type in ls to see if you got a lessons directory. If not, we'll do typing in mkdir space lessons. Very good. Now we'll type in sudo space chown minus capital R column students slash home slash Mario slash lessons. Very good. Now let's check the groups using the ls-l in our home directory. Now, in order to give permissions to read-write to our students group, we can simply type in sudo chmod space -r space g plus rwx slash home slash Mario slash lessons. Now, if we check the permissions again using ls-l, now we can see that the group permissions have changed to read, write, and execute. Now, let's create the exam directory by typing in mkdir space exams. Now, using the FACL file access control list, we'll give access to our teachers. In order to do so, we'll simply type in sudo space set FACL space -m space g column teachers column rwx space minus capital R space slash home slash Mario slash exams. Very good, we just achieved the same result we got previously using the FACL method this time. Now, to check the file access control list, we'll use the get FACL command on slash home slash Mario slash exam, and this will show us the full file access control list. All we need to do is exclude our students from having access to our exam directory. In order to achieve that, we will be using the FACL command. We'll type in sudo space set FACL space -m space g column students column no read, no write, no execute, space minus capital R slash home slash Mario slash exams. One last thing we need to sort out is give our teachers full access to the lessons as well. We'll do that by typing in sudo space set FACL space -m space g colon teachers colon rwx space minus capital R space slash home slash Mario slash lessons, and hit enter. And that's about it. Now let's double check by typing in get FACL slash home slash Mario exams, and we can see our student group has no access to our exam directory. We can actually triple check that by logging into one of our students' accounts as well. We'll type in su space Alice. Type in the password for Alice. Very good. Now we'll do pwd to see what directory we're in. We'll do a quick ls. Very good. Now we'll try to cd into our exams directory. That doesn't work. Alright, we'll try ls-l space exams. That doesn't work either. Well, as you can see, I cannot access the directory exams as a student. Sometimes you might want to have more than one user being able to access the sudo command. For that, we'll be using one of our created users. In my case, I'll be using the user Alice. First, I will log in as Alice by typing in su space Alice, then typing in the password for the user and hitting enter. Very good. Now, just to double check, I'll be typing in who am I and hit enter. Sweet. And before we begin, we'll type in clear and hit enter again. Now, from our terminal, we'll test to see if our user is part of the sudoers file, and for that we'll simply type in sudo space nano space slash etsy slash sudoers. Then we'll type in the password for our user Alice. And as we can see, our user is not present in the sudoers file. So in order to edit the sudoers file, we will have to log in as root. For that, we'll simply type in su and hit enter. Then type in the password for our root username. Then using the VM editor, we'll type in vm space slash etsy slash sudoers and hit enter. Now, with our VM editor open, we'll type in I for insert, navigate under our root user and the administrative user, in my case Mario. And underneath your user, in my case Mario, we'll type in our new user we want to add, in my case Alice, and then hit tab, just copy the sequence above here as well. And after you finish typing in everything, hit escape and then type in column, WQ, an exclamation mark, and hit enter. Very good. Now from our terminal, we'll type in su Alice, then type in who am I, just to make sure we're logged in as our desired user, in my case Alice. And now I'll simply type in sudo space nano space slash etsy slash sudoers, and there we have it. Our desired username is part of the sudoers file. To exit, simply type in Ctrl+X. Very good. Now this will conclude our short subchapter. In this short subchapter, we'll go over on how to see what groups a user is part of and what users are part of a certain group. For example, if we wanted to see what groups Alice is part of, we would simply type in groups, Alice, hit enter. And there it is. Alice is part of the Alice group as well as the students group. Now, if we wanted to see what groups is Mr. Smith part of, we would simply type in groups Mr. Smith and hit enter, and we'll see that Mr. Smith is part of the Smith group and the teachers group. Very good. Now, if we wanted to see what users are part of certain groups, for example, the students group or the teachers group, we would simply type in cat space /etc/ group and hit enter. And here we have it. The users that are part of the teacher group are Smith, and the users that are part of the students group are Alice and John. And with that, we conclude this chapter. A script commonly refers to a list of commands that can be interpreted and run by a program called scripting language. Commands can be entered interactively at the command line or listed line by line in a text file. Scripting languages are usually not compiled, they are interpreted at runtime. We usually use scripts to automate processes such as ATL jobs, doing archives, general system administration tasks, or file backups. Basically, you can use scripts for nearly any computational task. Now, a shell script is an executable text file in which the first line usually has the form of an interpreter directive. The interpreter directive is also known as a shebang directive and has the following form: *! Interpreter, or you can say #bang interpreter and an optional argument. Now, interpreter is an absolute path to an executable program, and the optional argument is a string representing a single argument. Shell scripts are scripts that invoke a shell program. For example, #bang/bin/sh invokes the Bourne shell or other compatible shell programs with the bin directory. Now, #bang/bin/bash invokes the bash shell. Shebang directories are unlimited to shell programs. For example, you could create a Python script with the following directive: #bang/user/bin/env/python. Now, before we create our first Hello World shell script, let's make sure we're in the right directory by typing in pwd and hit enter. Now, if we're not in our home user directory, we'll just type in cd/home/user. In my case, it'll be Mario, so cd/home/Mario. And now I'll type in pwd again and hit enter. Very good. Now, in order to create our first Hello World, we'll simply type in touch hello_world.sh. The sh extension is a convention used to indicate that the file is a shell script. Now, using the echo command, we'll append the pound and bang and turn our text file into a bash script. For that, we'll simply type in echo shebang/bin/bash redirect hello world.sh. Now, we will append another line of text. We'll type in echo echo hello world space redirect hello _world.sh. Now, before we run our bash script, we need to make it executable. So first of all, let's check the permissions for our new file hello_world.sh. For that, we will simply type in ls-l space hello_world.sh. As we can see, our script is readable and writable, but the lack of the x means it's not executable. We can make it executable for all users by using the chmod command. We could simply type in chmod space +x space hello_world.sh. Now, if we check our permissions for our file again, typing in ls-l space hello_world.sh, this shows that our script is now executable for all users. Now we can finally run our bash script by typing in /hello_world.sh. After we press enter, we see the text hello world appears on the command line. For our basics in shell scripting, that will be it. In this section of our course, Ultra Learning Linux, we'll be going through some useful commands and techniques that will make using the command line much more friendly and easier. The first command that we will cover is locate, probably the easiest command to use. Now, let's say for example we wanted to find our first file that we created. For that, we'll simply type in locate space hello world. And there we have it. We have located our first file. However, the locate command ain't perfect, and sometimes the results may be overwhelming you, giving you too much information. For example, let's try and locate our username by typing in locate, in my case Mario. As you can see, we got way too much information. And on top of this, locate also uses a database that is usually only updated once a day. So if you only created a file a few minutes or even hours ago, it still might not appear in our list until the next day. Now, the second command would be whereis. If you're looking for binary files, you can use the whereis command to locate it. This command returns the binary and the source of the man page if available. Now, let's type whereis bash. As you can see, whereis return the bash binaries and man pages, rather than every occurrence of the word bash. The which command is even more specific and only returns the location of the binaries in the path variable in Linux. So if we typed which bash, we will only receive the single binary file listed in the path variable. If we desire to perform a more powerful search, we could use find. The find command is the most powerful and flexible of the searching utilities. Using the find command, we can use a number of parameters, such as the file name, the date of creation or when it was modified, the owner, the group, permissions, and size. The basic syntax for find would be find, directory, options, and expression. So if we wanted to find our first file, we'd simply type in file, find, followed by the directory we want to start the search in our case, /home/Mario, followed by minus, type F, and lastly minus name, space our first file. Very good. A search that lurks in every directory can be slow. That is why in order to speed it up, we can use it in the directory we most expect to find the files we need, as in our case the tutorial directory. The grep command and pipes. Oftentimes, when using the terminal, you'll want to search for a particular keyword, but that most often you'll be using the grep command. Grep command is often used when the output is piped from one command to another. The pipe command, denoted by a vertical slash, immensely extends the functionality of shells. It allows us to chain together sequences of filter commands, so accordingly to the output of command 1 because the input of command 2, and so on. Pipe is short for pipeline. So for example, if we want to list the content of our users folder, in my case Mario, I would do ls space Mario. And now using a pipe and the grep command, I can do pipe and then grep, and we will grep our tutorial directory. And there we have it, we just searched the listing of our directory. But for example, let's imagine we need to run the permissions for our specific directory tutorials. We'd simply type in ls space -Mario space pipe space grep space tutorial. As you can see, we have received the information in regards to permissions and groups to our tutorial directory. Sometimes you'll be doing searches on directories that might have the following files: cat, what, mat, and bat. The wildcard (?) is used to represent a single character. So the search for (a) would find cat, mat, and bat, but not what. Now let's create the following files: cat, what, mat, and bat. We'll do that by typing in touch, cat, what, mat, and bat. Now we'll type in find, @ So we get bat, cat, and mat, but not what. Now there's another wildcard, and it's the asterisk. The most used wildcard is the asterisk, to be fair, which matches any character of any length, from none to an unlimited number of characters. For example, if we perform the search find *@ we will find all the names of the files containing @. Now let's remove the files we created earlier, cat, mat, bat, and what. In order to do so, we'll simply use the wildcard asterisk and type in rm space * and hit enter. Now check for the content of our directory by simply typing in ls, and there we have it. The files have been removed. Now, just before we move to our next chapter, there are just 2 more concepts and commands that I want to share with you because they will help you through your Linux journey. The first command is who am I? This is short and a simple command that displays the user you are currently logged in. As a Linux administrator, you will have access to a number of users, and it's always important to know and double check what user you are logged in as. Now, the second command is date, another easy and short command. This command simply displays the day, the month, the day of the month, the exact time, the current time zone, and the year. You can use this in a multitude of ways, even just checking the time while you're working on your command line. Now lastly, I'm going to give you another tip on the clear command. The clear command is most often used when you want to clear your screen and maintain a more clear workspace. Also, a key shortcut that I see many leading Linux engineers now use is Ctrl+L. This shortcut just does the same thing as clear. It clears your screen. So for example, if we typed in ls-l and hit enter, and want to clear our screen, we could simply type in clear, or if we type ls-l again and hit enter, this time we'll simply type in Ctrl+L and we'll clear our screen as well. It's simply a matter of choice, but efficiency is key in Linux, so I'll let you decide which one of the 2 methods you will be using. With that being said, this concludes chapter 6 of Ultra Learning Linux. process is nothing more than a piece of running code on your computer that is executing some task. Every process has a process ID, and every process has a parent or a so-called PID, because every process is started by a parent. There is a process, however, that is not started by another process, and that's the init process that has process ID number 1. So in order to see what processes are running on our system, we'll simply have to type in PS. Now, in order to see the number 1 process, we'll type in PS space -F space 1 and hit enter. Now we can see that the PPID, meaning parent process ID, is 0, and that the PID, the process ID, is 1. So the init system on my machine is going to be in systemd. Now you might be asking, well, if the parent process ID is 0, then what actually started the process? Well, the truth is, the Linux kernel has started it. Basically, a system is broken up into 2 pieces. One piece is something we call kernel space, and the other piece is something we name user space. Now, what is happening when you boot your machine? It calls the Linux kernel. The Linux kernel does a lot of different things, but once it finishes everything it does in kernel space, the only thing it does in user space just calls one process. And in this case, it will be the systemd and what comes after it. When systemd gets called, or whatever init system we're using, that init system is now responsible for starting all the other processes that the computer needs to run in user space. So now we'll just run a simple command and we'll analyze exactly what's happening. First, let's clear our screen by typing in clear. Now for the command, we'll be using ls space -l. This command lists all the files within our directory as we already know. So when we run the ls -l command, what's happening is that the current process, which is a bash shell, it forked into 2, and then a copy of itself was replaced with the command ls. Now what we have running is bash, our original shell, then a child process named ls, which runs, that is, the so-called fork and exec. It first forks, which makes a copy, and then the exec replaces that process with another process. We'll be demonstrating the function of exec by operating another terminal. So we'll open up another terminal, and we'll run exec space ls space -l. As you can see, running the exec command, the terminal just disappears, and the current bash will replace with ls. This happens because in the first case, bash executes ls, and then once ls is executed, it goes back to bash. But if we were to exec, it replaces the bash with ls, and then it just disappears. So if I were to run ls -r right now, the same exact thing is happening. We're still running exec. It's just running exec on a forked process, so that's why the terminal does not exit. Now, this will conclude our short subchapter on process management. The first command we're going to use is ps. Some may even call this the Linux administrator's best friend. The ps command will show us information about the running processes. So if I were to run ps without no argument, we get the current processes in the shell. If we run ps space f, we are able to see the hierarchy of the commands and the status of the commands. So in order to have a better understanding, we'll be going through a few examples. For that, we'll be using the sleep command. So if I were to type in sleep space 1, and hit enter. What the command would do, it will sleep for 1 second and then it will end. This might be good to keep a command running for a long time. So let's start by typing in sleep space 250 and hit enter. Now you can see it just freezes. So what happened here is we ran the command sleep, it made a copy of the process, it forked, and then it ran exec on that forked process, and now we have bash and the child process sleep. And because sleep was executed by bash, it inherits standard in, standard out, and standard error. So right now, as you can see, we're not able to run any other commands in the terminal, and that is because it ain't owned by bash anymore. So even if I were to type ls -l right here, it won't do anything or won't get any results. So now if we want to regain access to our terminal, we can do one of 2 things. We could either kill the process or suspend the process and figure out what we'll do with it later. So in order to just end the process, we'll just type in Ctrl+C, and that will send in a SIGINT signal, which would terminate it. But let's say that that was a process that we still want to have up and running. Then that wouldn't be the ideal scenario to end it. So let's start this over. We'll type in sleep 250. But this time, we're going to suspend the process. And to suspend the process, we'll simply type in Ctrl+C. Now we've regained access to our terminal, and we still have one process running. In order to see the jobs you have running, you can simply type in jobs in our terminal and hit enter. So if I were to type in jobs, we can see we have one job and it's currently stopped. We can also have a look at our process table by typing in ps space f and hitting enter. We can see now that bash has two child processes. It has sleep 250 command and then the ps f command that we just ran. So in order to start the sleep process back up, we can do one of two things. If we wanted to start in the foreground, and because we only have one process, we could just type in fg, but for better comprehension, we'll be using the full syntax, and that is fg space 1, that being the job number, followed by the pwd number, and hit enter. But still, if we manage to do it this way, we won't be able to use our terminal. So then the ideal way is to start the process in the background. In order to do that, we'll have to suspend it again. We'll be using Ctrl+Z and we'll type in bg. As we only had one process in the job table, we didn't have to use the full syntax. So at the moment, we have access to our terminal and sleep is running in the background. Now, one way of verifying this is by typing in ps space f and hitting enter. And here it is. And here, where it said T, it now says S. T means it's in a stop state, and S means it's in an interruptible sleep state. Now, let's clear everything by either using clear or Ctrl+L. Now, as you recall, in order to have our sleep 250 run in the background, we have to start it in the foreground. We suspend the process and then start it back in the background. But that's a bit tedious, ain't it? So we could do is actually start jobs directly in the background. And the way to do that is just by using the end sign. Now, for our next example, we'll be using multiple jobs. So if we wanted to start, let's say, these three processes, we'll type in these three commands. Sleep space 900 space end, hit enter. Then sleep space 901 space end, hit enter. And then sleep space 902 space end and hit enter. So we start these three new processes. They are all sleep processes, sleeping for 900, 901 and 902 seconds. As stated before, the 1 in front means that this is the job number and the number after it is the process ID. So if we were to run the jobs command, we can see sleep 900 is the first job to run. Sleep 901 is the second one, and sleep 902 is the last one. The plus sign here means that this is the last job we have sent to the background, and the minus sign means that this is the second to last process we sent to the background. Now let's type ps space f and hit enter to check the PID or the process ID. Now if we wanted to bring one of the jobs in the foreground, let's use sleep 902 for this one. For example, all we need to do is type in fg followed by the job number, in our case 3, and then the process ID. Now we have sleep 902 enter the foreground. We could also achieve this by typing in fg space percentage and 3 being the job number. Now let's terminate this process by typing in Ctrl+C, and let's have a look at the job tables again. We'll type in jobs. Very good. Now let's cancel the remaining jobs, typing in fg percentage 2 and do Ctrl+C to terminate that one. And then fg space percentage 1, and we'll terminate this one as well by typing in Ctrl+C. And now when we type in jobs, you can see that nothing shows up because there aren't any more jobs. Now for this last example, I'll be starting up a few more sleeping jobs, but this time we'll be using another terminal to send kill signals, basically shutting them down in a different way. Now let's start up sleep 2000, sleep 2001, sleep 2002, and sleep 2003. Type in jobs. Now we have our processes running, and these are all the PIDs for them. So now using our second terminal, we'll gather more information about these processes. We'll type in ps space ax space pipe space grip space sleep. This gives us the processes that have sleep in the command, and we can see that these 4 PIDs match these 4 PIDs that we first started. Now the way that kill command works is you type kills, then the signal, then the PID. There are a lot of kill signals on the system. You can get a list of all the signals by typing in kill space -L, and this shows us all the signals with different signal numbers, but for this example we're only going to be focusing on a few of them, and that will be 15, which is a sig term, a 2, that's a sig init, and a 1, and that's a sig up, and of course a 9. This is sending a sig kill. So if you do kill with no signal, it just assumes you're doing sig term as in 15. Now let's do just a basic sig kill. We'll try and kill the signal sleep 2001. In order to do so, we'll type in kill space -15 and then the PID. After we do so, we come back to our first terminal, type in jobs, and see that sleep 201 is terminated. Even though it's not a process anymore, we'll check that on our second terminal by typing in again ps space ax space pipe space grep space sleep. It is still visible in our jobs table because the shell still knows about it. Now, to better understand this, whenever you send a sigterm or a siginit or a sigup to a process, normally the process will exit, but it won't necessarily do so every single time, because some applications can listen for a signal and then still have to process in some way. This is the reason why sigkill exists, or kill-9. When you do a kill-9, the kernel will just remove the process from the process table and the application can't do anything about it. Now, the obvious question that arises is, why not kill-9 everything? Well, whenever you do a kill-9, it's considered a dirty shutdown of that application, more like unplugging your computer from the electrical outlet just to shut it down. Now, on the other hand, when using a kill-15 aka sigterm, that application still has time to save and write a queue to a file, just to not encounter any errors or get corrupted, all of this just before it shutdowns. Because when doing a kill-9 aka sigkill, it might not save properly and then your whole file might be corrupted. However, kill-9 is still perfect for dealing with a misbehaving process. All in all, this will conclude our overview of process management, and this would be the end of chapter 7 as well. First and foremost, before we can even use an OpenSSH server on our computer, we need to enable the internet on our Linux virtual machine. In order to do so, simply start your Oracle VM VirtualBox Manager. Select your VM, in our case CentOS. Go to Settings. In Settings, select the Network tab, and from where it says Attach to, simply select Bridge Adapter and select your network. In my case, Realtek PCEI. Then click OK, and you should be all ready to continue to your next subchapter. After we enable internet on our virtual machine, we will need to download PuTTY. Basically, PuTTY is a free implementation of SSH for PCs. Now go on Google and search for PuTTY. Here's the first link saying download PuTTY from putty.org. Click on this link then. Now click here where it says you can download PuTTY from here, and select the appropriate version for your machine, aka computer. Once downloaded, just install the software normally. Very good. Once installed, we can advance to our last subchapter. The OpenSSH service is used to access Linux systems using the command line. Using SSH, we can log in remotely to another machine and use the command line. From our terminal, let's first make sure we have SSH installed. For that, simply type in SSH, and there we have it. We have SSH installed. Now, in order to check if indeed we are running SSH on our session, we will simply type in ps space minus af space pipe space grep space sshd. And here we can see that we are actually running the process as root from user admin sshd. Now, if for whatever reason you want to stop this process, you can do so at any time. But for now, we'll move forward into configuring our remote SSH service. Now, into your terminal, type in ifconfig, and where it says inet, just copy this IP to your PuTTY terminal. Make sure you have SSH selected on your PuTTY terminal and the port down to 22. Type in the host name and hit enter. Now, you will need to select the user you're going to be logging in as. In my case, it will be Mario. So I'll type in the user Mario, and now I'll type in the associated password with this user. And there we go, we're logged in as a user from another terminal. Now, in order to perform some routine checks, we'll move into our tutorial directory using the absolute path. We'll type in cd space /home/Mario/tutorial. And here we're going to create a new file by typing in touch space remote 123. Now from our terminal we'll navigate to the same directory by typing in cd /home/Mario/tutorials. Then we'll type in pwd just to double check. Very good. Now from our terminal we'll do an ls check to see if the actual file was created. And there we have it, remote 123. Now from our terminal we'll use the echo command to append some text to it. We'll do so by typing in echo space open SSH space protocol space double redirect space remote 123. Now from our PuTTY session, we'll type in cat space remote 123. And there we have it, OpenSSH protocol. Before we finish, just delete this from our party session by typing in rm space remote 123. Now back to our terminal, let's check for the file, and there we have it, our file is deleted. And with that, we conclude our chapter on the OpenSSH service. Compression, as the name implies, makes data smaller, requiring less storage capacity, making the data easier to transmit. We can categorize compression as either lossy or lossless. Lossy compression is very effective, reducing the size of the files by quite a lot, but the integrity of the information might be lost. This compression mainly works for graphics, audio and video files, where the difference between an MP3, MP4, PNG or JPEG might not be as noticeable. Even though on a high-end monitoring system you can obviously spot the missing artifacts between the 40 megabytes and his copy MP3 of 4 megabytes. But all that being said, we need to remember that the compression ratio is very high and the resultant file is way smaller than the original. However, lossy compression can't be used when sending software or files, as their data integrity is very important. That is why on this chapter we'll be focusing on lossless compression. Even though it might not be that effective, it's far more important to preserve the integrity of our files. Now, before we can compress actual files, we first need to combine them into an archive. For that, we'll be using the tar command. Tar stands for tape archive. The tar command creates a single file that we refer to as an archive, tar file, or tarball. Now, let's go over in our tutorial directory and create a new directory named chapter 9. In our directory chapter 9, we shall create 3 files with the touch command. And that will be touch space music1.mp3 space music2.mp3 space music3.mp3 and then hit enter. Now we'll just double check by typing in ls. Very good. Now we'll type in tar space -cvf space music.tar space music1.mp3 space music2.mp3 space music3.mp3 and hit enter. Now let's type in ls -l and here we have it. We just archived our music files. Now, as you can see, the newly created archive has a significant size difference, and although this overhead can be significant with small files, it becomes less and less significant with larger and larger files. Now, in order to display the content of our archive without extracting any of the files, we can simply type in tar space -t vf space music.tar and hit enter. And there we have it, our files contained within our archive. Now, let's say we wanted to back up our music archive. For that, we'll simply create another backup directory. We'll type in mkdir space backup and hit enter. Then we'll type in cp space music.tar space backup and enter. And then we'll cd onto our backup. We'll type in cd space backup. And here we'll want to actually extract our files from the tarball or the archive. For that, we'll simply type in tar space -xvf space music.tar and hit enter. Now, if you want to extract the files without displaying their names, you can simply do that by not typing in the v. Now, to remove the music files, we'll simply type in remove space music1.mp3 space music2.mp3 space music3.mp3 and then hit enter. Now, let's do a quick ls check. Very good. Now, simply extract the files again from our tar archive by typing in tar space -xf space music.tar. Now, let's do another quick ls check, and there we have it. We just extracted the files without them being displayed. And that will conclude our subchapter 2. As we already know how to archive a file, let's move to actually compressing them. There are 3 types of compression we're going to look at. The gzip that uses the extension .tar.gz or the tgz. Then we got the compression bzip. This compression uses the extension .tar.bz2. And then we have the compress command that uses the extension .tar.z. All of these 3 methods can compress files, but they all have different algorithms and different compression ratios. We'll start off with the gzip, as it is the most commonly used compression utility in Linux. Before we do, let's see the actual size of our files. We'll type in ls-l and hit enter. Sweet. Now let's type in gzip space music.tar and hit enter. Very good. Now type in ls-l again and hit enter. And there we have it. Now let's decompress the archive by typing in gunzip space music.tar.gz. Now let's type in ls-l again and hit enter. Very good. Now we'll compress using bzip2. This method has an even better compression ratio. The files will be even smaller. Now to compress our music.tar file, we'll simply type in bzip2 space music.tar and hit enter. Very good. To uncompress the file, we'll simply type in bunzip2 space music.asterisk or hit tab for completion and hit enter afterwards. Very good. Now the last and least used compression method used is compressed. Simply type in compress space music tab for autocomplete and hit enter. We'll do a simple ls space -l to confirm. Very good. Now in order to decompress, we'll simply type in uncompress space music and hit tab to autocomplete. Now we'll type in ls-l again, and there we have it. And with this we'll conclude our chapter 9, compression and archiving. We have compiled a series of short answers, but we will leave an additional information in regards to the subjects for a more in-depth and better comprehension. You can simply pause after each question to read and study in more depth. Now, without any further ado, we'll start with our first question. What is Linux? Linux is an operating system. The Linux file system and directory tree. Linux uses a logical system, the structure being different from Windows because Linux doesn't have a physical drive such as a C drive. The mount concept. Simply type in mount, the absolute path of device, and then the mount point that usually is /mnt, or you can try // space /etc/ /fstab. How would you look up something you don't know? We simply type in the man pages and type in the command we are looking for. Linux kernel. The kernel is a computer program that is the core of a computer's operating system with complete control over everything in the system. In other words, the kernel connects an application software to the hardware of the computer as illustrated below. Linux shell. The shell is a program that takes commands from the keyboard and passes them to the operating system, the kernel, for performing. During the initial days, shell was the only mode for communicating with the kernel. Linux bash. Bash is short for born again shell. It's a replacement for the original shell /bin/sh. The Linux built-in sequence. BIOS, MBR, grub, kernel, init or systemd, and services. How do you check the kernel version of the Linux system? To check for the current version of our Linux system, we simply type in uname space -a in our terminal. Check the current IP on your Linux system. To check for the current IP on our Linux system, we can simply type in fconfig in our terminal and hit enter, and then the IP is our inet for npos3. How do you check for free space in Linux? To check for free disk space in Linux, we simply type in our terminal df space -ah, all human readable, example 1 kilobyte, 133 megabytes, 3 gigabytes, and so on. How to see if a service is running in Linux? To see if a service is running in Linux, they are usually using a systemd init, so we simply type in systemctl space status and the service we want to check. How to check the size of a directory's contents on disk. For that, we simply type in du space -sh. As you can see, we got this amount of size in our tutorial directory. How to check for open ports on a Linux machine. We simply type in netstat and hit enter. This brings up a lot, so in order to narrow it down, you might want to type in netstat space -topen. How to check the CPU usage of a process. In order to check for the CPU process, we simply type in ps space aux space pipe space grep space nginx or top. How different is Linux when compared to Unix? Linux is a Unix clone written from scratch with the assistance of hackers across the net. What is the importance of the GNU project? The GNU project is a result of the free software movement started by Richard Stallman in 1984. The GNU project was intended to create a Unix-like OS, but free and open source. This led to the birth of Linux OS, Linux kernel plus GNU utilities. What are daemons? The processes that are waiting or running in the background and are performing different tasks are known as daemons. What is Lilo? A Lilo is a Linux loader, basically a bootloader for the Linux operating system. Lilo is an acronym for Linux loader, basically.